Hi everyone, welcome to PrepFusion. So a very important concept and a very interesting concept we are going to study now, concept of eigenvalue and eigenfunction for a particular LTI system. So this concept will go only for LTI system. So let's just say this is an LTI system which is having an impulse response of ht, the applied input is xt and the output will be yt. Okay. So how the output yt will be defined for an LTI system? Yt will be given as xt convolution ht, right? So now what you are doing, you are applying a particular xt and you are receiving output yt. So when you applied a particular xt, the output you received is yt is equals to xt only, but multiplied with the constant factor. What you did, there was an LTI system, there was a box. To this particular box you applied an xt and you received some output yt. That output yt was same as xt, but multiplied with the constant factor. This factor k, this constant factor k could be anything. K is constant. K is a constant. This k could be anything. It would be real, imaginary, or complex. It could be anything. Like it could have a value of 2, or it could have a value of minus 2 as well. It could have a value of 2j, it could have a value of minus 2j, or it could have a value of 2 plus 2j, or it could have a value of 2 minus 2j. Basically, it should be a complex number, that's it. So if this is the scenario, so this k is known as eigenvalue of LTI system. Eigenvalue of LTI system. And this xt is known as eigenfunction of LTI system. So are you able to understand what we are doing? So there was a block. This block was having an impulse response of ht. So the impulse response of this particular LTI system was ht. You applied a particular xt and you received output yt. Yt was same as xt but multiplied with the constant factor. That constant factor could be anything. It could be real, imaginary, complex. Now if this is the scenario, then that constant value, that particular constant value is known as eigenvalue of LTI system, and this particular xt is known as eigenfunction of the LTI system. Is that okay for you? Did you understand the meaning of eigenvalue and eigenfunction? So this is very important. You need to understand the meaning. Now, if I am representing h of t with h of s, that means I am representing this LTI system in s domain. So this is known as transfer function of LTI system, right? Transfer function of LTI system, and the applied input is x of s. What will be your output? Y of s, and y of s is given as x of s into h of s. And if I am defining my h of t in omega domain, if I am defining my h of t in omega domain, so this is your h of omega. What will be your input? X of omega. What will be your output? Y of omega. So y of omega is defined as x of omega dot h of omega. Convolution in time domain will be multiplication in frequency domain and multiplication in s domain. So this thing you already know. This was just a basic revision. So from this slide we just understood the meaning of eigenvalue and eigenfunction, right? So let's see a question. What is the question? That there is an LTI system ht. You are applying input xt which is e to the power s naught t. Now let me know what will be your output yt. This is what you need to tell. By the simple definition, you don't need to apply any Laplace transform, Fourier transform, nothing. By the simple definition, you need to let me know what will be your yt. So let's start. Okay. So this is your xt. ht is there. Impulse response of LTI system is ht and output is yt. So yt can be given as xt convolution h of t, and this I can define as. So what I will do, h of 2 as it is, but xt inverted and then shifted yt, and then you need to integrate with respect to tau. So this is how you open the convolution. In the basics of signal we have studied how to open the convolution, right? So what would be your yt? So h of tau as it is. In place of xt, what you need to put? In place of t, what you need to put? Minus tau plus t. So in place of t, what I need to put? Minus tau plus t dot d tau. How I can open it? Minus infinity to infinity h of tau e to the power minus s naught tau e to the power s naught t dot d tau. Now you are integrating with respect to tau. So this term is a function of t. So this will become a constant. You are integrating with respect to tau. So this is a function of t. So it will become a constant. So what you are getting? E to the power s naught t, e to the power s naught t minus infinity to infinity h of tau e to the power minus s naught to d2. This is your yt. Now, how do you define your Laplace transform? H of s. If I need to define h of s, how will I define it? Minus infinity to infinity ht e to the power minus infinity dot dt. For a particular ROC, for a particular region of convergence, this will be defined for a particular region of convergence. Now, if I want to ask you what is the value of h of s naught, that would be h of t e to the power minus, in place of s you need to put s naught dt, right? Can I change the variable from t to tau? What I am doing, I am just replacing t with tau. Can I do it? Surely I can do it. Just I am replacing t with tau. So what I am doing, h of s naught will be minus infinity to infinity h of tau e to the power minus s naught tau d tau. In place of t I just put tau, nothing else, right? So what is this particular thing? Here it is, right? So what is this? This is h s naught. H s naught. So what is your yt? From here what do you see? Your yt is coming out to be, this is your h s naught, h s naught into e to the power s naught t. This is what your yt is coming out to be, right? So let me know, will this be a constant value? Yes, surely it will be a constant value. Let's just say h of s was 1 upon s plus 2 and s naught value was 2. So you will put this s naught constant value here. So s was replaced with the constant value. So now it would become 1 by 4. So it will be a constant value for sure. So this is a constant value. And what is this? This is your xt only. So what is your yt? From here what you can see, my yt is coming out to be some constant value dot xt. What does that mean? This constant value is your eigen value and e to the power s naught t is your eigen function, right? So this constant value is your eigen value and this is your eigen function, right? Understood? But here there is a catch. Something wrong we have done. That I am not gonna tell as of now. So if you are making your own notes, then just leave a space of 2 to 3 lines at least. That you need to leave a space of 2 to 3 lines after this. I am gonna write down a very important point here. We are missing something. As of now, what does it look like? That e to the power s naught t will be a eigen function of any LTI system. S naught value could be anything. It could be anything. It could be real, imaginary, complex. It could be anything. Real, imaginary, complex. It could be anything. So as of now, it feels like that e to the power s naught t will always be a eigen function of an LTI system, because whenever I applied e to the power s naught t, what did I get to know? That yt is coming out to be k into s naught t. This k is h s naught. So that means e to the power s naught t will be a eigen function of an LTI system. But it is not always true. When it will not be true, either you can think about it or you can wait. What is the catch? You are putting this s naught value in h of s. And h of s is defined for a particular ROC only. So can you blindly put the value? Like, can you blindly define h of s naught? What I am saying, can you blindly define this particular thing? So we will see about it, we will discuss it. So we will discuss it with respect to a question, which is this question. But before that, let's write down the conclusion. What is the conclusion we have written down? The conclusion is yt is equals to, if I am saying the h of s is my transfer function of LTI system. What is this h of s? Transfer function of LTI system. Or at least h of t will be defined. From there I can get h of s. So h of s is the transfer function of LTI system. So if I know that transfer function of LTI system, if my applied input is e to the power s naught t and I need to comment on yt, so what I will do, I will put h of s, but in place of s I will put this particular value, which is s naught, and then I will just write down input as it is. So yt will be equals to the input only, but multiply with the constant factor, and that constant factor will be h of s naught. Is that clear to you? So this s naught I need to pick and I need to put it here. and my job will be done. But here there will be one important line as well, and that important line you will understand from here. So what you need to do, ht is given, xt is given, you need to find yt. So you will find yt with this concept. Along with that, you will find yt with the simple convolution property. You know how to solve the convolution, right? So by the two methods, you will find out yt for each question. So there are 4 questions, 1, 2, 3, 4. So for the first one, this is our impulse response and this is our input, that is e to the power 2t. So inputs are in the form of e to the power s naught t, right? E to the power s naught t. S naught value is 2. Inputs are there in the form of e to the power s naught t. Inputs are there in the form of e to the power s naught t. Inputs are there in the form of e to the power s naught t. Right? Here s naught value is 2, here s naught value is minus 3, s naught value is 3, s naught value is 1. Right? So this is the scenario. So first let's solve it with the concept of eigenvalue and eigenfunction. How do we solve it? That sir, what will be my h1 of s? What would be your h1 of s? h1 of s will be sir 1 upon s plus 2 with the ROC being real part of s should be greater than minus 2. That means sigma should be greater than minus 2. So sir, this is my h of s. Sir, what kind of input I am applying? Sir, my applied input is e to the power minus 2t. And what kind of output I will be getting? Oh no, sorry. My applied input is e to the power 2t. Really sorry. My applied input is e to the power 2t. So what kind of output I will be getting? Sir, it will be equals to e to the power 2t only, but multiply with the constant factor. So what I need to do? I need to put this 2 here. What I need to do? I need to put this 2 here. So what I will get? 1 upon 2 plus 2 into e to the power 2t. So sir, my answer would be e to the power 2t by 4. So this is the answer I am getting. Let's verify if this answer is correct or not. So what we will do? We will solve it by the basic method. What does the basic method says? Basic method says that your yt would be equals to this I am calling as x1t. This I am calling as x1t. So yt would be equals to x1t convolution with h1t. Let's call it y1t only. So y1t is equals to h1t convolution with x1t. So what I will do? I will keep h1t as it is, or I can say h12 as it is. For the x signal, what I will do? Invert and then shifted by t and then integrate with respect to tau. So let's see what I am getting. What is my h1 tau? H1 tau is e to the power minus 2 tau u tau. What about this one? E to the power 2 minus tau plus t dot d tau. Directly I can see that e to the power 2t will be coming common. E to the power 2t will be coming common. Minus infinity to infinity. Now since there is u of tau, so u of tau will interchange the limit from 0 to infinity. Will change the limit from 0 to infinity because u of tau is 0 for t less than 0. So the limit will be changing from 0 to infinity. E to the power minus 2 tau. Then another e to the power minus 2 tau dot d tau is there. Right? This is another e to the power minus 2 tau. Right? So what we are getting? Simply this will throw 1 by 4. If you know the integration, this integration 0 to infinity e to the power minus 4 tau dot d tau. What you will do? E to the power minus 4 tau divided by minus 4, 0 to infinity. So e to the power infinity, e to the power minus infinity is 0, minus e to the power 0 is 1, divided by 4, another negative sign is already there. So this will throw 1 by 4. So this integration you can do on your own. This will throw 1 by 4. Right? So e to the power 2t by 4. Yes, this is the output we are getting, which is correct only. So in both of the cases we are getting it correct. So yeah, this is our answer. For the first one, this is our answer. Sir, why did you do all these kind of things? Directly you could have tell the answer. So yes, directly you could have tell the answer. Let's go to the next question. This is the question. E to the power minus 2t ut, x2t is e to the power minus 3t. So if I solve by the concept of eigenvalue and eigenfunction, because what is this? This is in the form of e to the power s naught t. So if I solve by that particular concept, that means s naught value I need to put here, minus 3 plus 2, and then input will be coming as it is. So what should be the answer? As per me, this should be the answer. If I solve by the concept of eigenvalue and eigenfunction, this should be the answer, right? But let's go by the basic definition. Let's go by the basic definition. x2t convolution with h1t, right? So without applying the formula, what I am doing, I am directly writing down the results. So this remains as it is, e to the power minus 2 tau u tau remains as it is. Another one inverted and then shifted, right? So I can see that e to the power minus 3t will come common, minus infinity to infinity, e to the power minus 2 tau. Since there is u tau, so this minus infinity to 0 part will be gone. So the limit will change from 0 to infinity. Here what I am getting, e to the power 3 tau dot d tau. Now look closely, e to the power minus 3t. Now see here, 0 to infinity, e to the power tau dot d tau. What is the graph? E to the power tau. This is the graph. What I am saying, I am drawing the graph of e to the power tau versus tau. So what will be the area here? Infinity. Are you able to understand this point? What will be this area? This area will be infinity. No, you can check as well. How will you check? E to the power minus 3t is the constant value. E to the power tau, you put from 0 to infinity. What is the value of e to the power infinity? That is infinity only. So what is the answer you are getting? Infinity. So one guy is saying that your answer is minus e to the power minus 3t, and one guy is saying that answer is infinity. Which one is correct? Surely this one is correct, because here we went with the basic method. This is just a way, and here we are getting infinity answer. So what was the issue? In this one we were getting the correct answer, but here we are getting the wrong answer. What is the issue? Where the issue came into action? This is the most important point of the complete chapter. I should not say chapter, topic. This is the most important point of this topic, which is known as eigenvalue and eigenfunction. So where the error came into action? The error came into action here. This is very important. So what is your h of s? My h of s is 1 upon s plus 2. My h of s is 1 upon s plus 2. That's it? No. Ut is there, no, so I need to define the ROC as well. Real part of s greater than minus 2. If I make the s plane, where will be minus 2? Here will be your minus 2. So where is your ROC? Real part of s greater than minus 2. This is the ROC. What does this mean? That means in this particular h of s, will converge only for real part of s greater than minus 2. That means at all these points, let's just say the value of s is minus 1 plus 3j. Value of s is minus 1 plus 3j. It would be somewhere here. So yeah, at this point it will converge. But if the value of s is minus 3, so at minus 3 this transfer function will not even converge. So when you are writing down the transfer function, you are writing down with the condition that this will converge only for real part of s greater than minus 2. So if you are putting the s naught value here, what is the value of s naught? S naught value is 3. So if you are putting h s naught, which is equals to h of minus 3, that means you are putting the s naught value as minus 3. So where will be minus 3? Here will be minus 3. So at this particular point, h of s does not even converge. So here only you went wrong. So next step are also wrong. So what is the bottom line? The bottom line is your h of s should converge at s equals to s naught, because you are putting the value there. What you are doing? You are putting this value in h of s. What does that mean? That this will be known as your eigenvalue. There is no doubt about that. This will be known as your eigenvalue, and this will be known as your eigenfunction. But only when s naught, only when h of s converges at s naught, or how you can write down that s naught should lie in the region of convergence of hs. So everywhere you will find out this particular thing, but this particular thing is also very, very, very important, and usually by the 100% of the aspirants this thing is missed. They miss this particular thing, that when you can put this s naught value, you can put this s naught value only when this particular s naught value is lying in the region of convergence of h of s. So whenever you are defining h of s, the first task will be always define the region of convergence, and there you need to check if your s naught is lying there or not. So in this particular question, what is the value of s naught? S naught value is 2. Here the value of s naught is 2, and where is the ROC? If I copy this particular thing, So where is the ROC? ROC is saying real part of s greater than -2. Real part of s greater than -2. So your s naught value is 2, which will be lying here. So yes, here h of s converges. So here you can put this value. Yes. But if your s naught value is lying out of the region, then yt will go to infinity only. Are you able to understand this point or not? A very, very good point about the eigenvalue and eigenfunction. So just by looking at e to the power s naught t, you cannot say that just by looking at e to the power s naught t, you cannot say that it will be eigenfunction or eigenvalue will be hs naught. No, the condition would be that s naught should lie in the region of convergence of hs. Is that clear to you? A very, very good interview question. Along with that, a very, very good question which can be asked in GATE examination as well. Okay, well and good. Let's see more examples. Now you will be able to solve these examples because now you will be checking the region of convergence as well. Because first you will say that sir, my h2s is 1 upon s minus 2. There is no doubt about that. But sir, here since there is ut, so my region of convergence is real part of s greater than 2. That means sir, now I will make my ROC. I will make my ROC where what I can see is that this would be my region of convergence. Now what I can see, if I make the block diagram, but this is my h of s, where the input is e to the power 3t. So this 3 I will directly put here. 3 I can directly put. Why is that so? Because 3 will be lying here. Now in place of 3, let's just say here in place of 3, 3 plus 2j was written. So 3 plus 2j also you could have written down because 3 plus 2j would be somewhere here, right? If this point is 3, 3 plus 2j would be somewhere here, or 3 minus 2j was written, then also you could have put. But if in place of here, in place of this s naught, 1 plus j was written, so 1 plus j would have been somewhere here, 1 minus j would have been somewhere here, or in this place s naught was written 2 only. What is the meaning of ROC? ROC is real part of s greater than 2. Greater than 2, not greater than equals to 2. That means this particular line will also not be included. This line will also not be included. After this line, whatever the values are there, that will be included. That means 2.00000001 plus j anything, j omega naught, anything. This will be included in the ROC. Right? Before this, nothing will be included in the ROC. So since s naught value is 3, which is included in the ROC, so now you can put this particular value here. Now you can put this particular value here, right? So my yt would be e to the power 3t would come divided by this s naught value will be put here. So yt would be e to the power 3t only. So yt would be actually equals to x3t only. And you can verify it with respect to the simple process as well. That what would be your yt? If I go by the basic definition, minus infinity to infinity, h of 2 as it is, other one shifted and then inverted. So 0 to infinity, e to the power minus 2 and e to the power 3t is also there, dot d 2. So e to the power 3t will come outward and the integration will throw 1. So this is the answer, e to the power 3t. This is the answer you are getting. So this integration you can solve. From the integration also we can verify that e to the power 3t is my answer. So this is the answer that we are getting because it is lying in the region of convergence. But here what will be the issue? Here the issue will be that sir, my h2s will be 1 upon s minus 2 only. So there is no doubt about that. With the ROC being real part of s greater than 2. Array, e to the power 3t. No, something else is there. E to the power t it is. E to the power t it is. This is your e to the power t. Okay. So here you are applying e to the power t. So sir, what will be your yt? 1 upon 1 minus 2 e to the power t. This would be wrong. Why is that so? Because sir, I know how to make the region of convergence. Here I can see that region of convergence is saying that the real part of s should be greater than 2. But where is my point? Where is my s naught value? I can see that my s naught value is 1 only. So this is my ROC which they are saying, but my S naught value lies here. This is my S naught value which is equals to 1. So what does that mean? That my Yt will be tending to infinity. That means output will be infinite. Unpredictable output you will have. Okay, and you can verify it. Surely you can verify it. How will you verify? Minus infinity to infinity. This as it is, e to the power 2 to u2 as it is. This one inverted and then shifted. Dot d2. So 0 to infinity e to the power t e to the power tau dot d2. So e to the power t 0 to infinity e to the power tau d2. So this will throw infinity only, because this particular integration throws infinity only. So what will be the answer? Infinity, which you can verify from this basic method as well. So did you understand the conclusion? The conclusion was written here only, that S naught value you can put, but h of s should be converging at s equals to s naught. Okay, or you can say s naught should lie in the region of convergence of h of s. Is that clear to you? Let's see some more questions and then we will do more discussion. So what I am saying, h of s is fed with e to the power 2t, e to the power minus 2t, e to the power j2t, e to the power minus j2t. So what will be your yt? Considering that, here you see, considering that h of s is having a ROC of entire S-plane. Now I am saying that ROC is entire S-plane. What is the meaning of entire S-plane? That every point will converge. So what will our S naught value? Our S naught value is 2. Our S naught value is minus 2. Sorry. S naught value is 2. S naught value is minus 2. S naught value is 2j. S naught value is minus 2j. Then S naught value will come out to be 2 plus 3j. 2 plus 3j. 2 plus 3j. And if I am showing it by dot, so here they are not the poles, right? They are not poles. They are just the S naught value. That's why I am not showing by cross. So next here I can see that S naught value is 2 plus 3j. 2 plus 3j. And what is the ROC? ROC is entire S plane. Entire S plane. That means entire this plane. So your h of s converges at all the point of s. So what will be your output? So output will be, sir, in place of s, what I will put? H of 2 e to the power 2t. Sir, in place of s, what I will put? H of minus 2 e to the power minus 2t. Sir, in place of s, what I will put? 2j I will put, because what is the value of s naught here? S naught value is 2j. You need to compare it with e to the power s naught t. So s naught value is 2j. So in place of s, what I will put? 2j. In place of s, what I will put? Minus 2j. Right? In place of s, what I will put? 2 plus 3j e to the power 2 plus 3j into t. Right? So whatever the input is there, that will come out as it is, but there will be a constant factor. That constant factor will be, in place of s, you put s naught. That's it. What about this one? 2 to the power t h of s yt. You need to find yt. 2 to the power t is there. Look, if I write down e to the power 2t, what is the meaning of e to the power 2t? That e to the power 2 and then power t. So this e to the power 2 is a constant value, no? I am not sure what is the value of e to the power 2, but it is a constant value for sure, right? E to the power 2, I can find out what will be the value of e to the power 2. So e square 7.38. So in place of e to the power 2t, what you could have written? 7.38 to the power t. Both are same thing. So similarly here, what is written? Constant to the power t. So can I write down this 2 to the power t? Let's just say this is my xt. Xt is 2 to the power t. Can I write down this in this manner? Because 2 can be written as e to the power ln 2. What I mean to say is that a can be written as e to the power ln a. But ln a will be defined only when a is greater than 0. Ln a will be defined only when a is greater than 0. Right? Because ln minus 2 is not defined. Ln 0 is also not defined. Ln 1 by 2, yes, it is defined. Right? So a has to be greater than 0. So what I have written? E to the power ln 2 t. If I compare it with e to the power s naught t, what is the value of s naught you are getting? Ln 2. From here, what is the value of S naught? You are getting ln2. So here what you can put? H of ln2, and whatever the input is there, input is e to the power 2 ln t, and this input can be written as, basically input is e to the power ln2 to the power t. So what I will be getting? H ln2, and what is e to the power 2? E to the power ln2, that is 2 to the power t. Is that clear to you? This is your yt. Dot means it is in multiplication. Did you understand this point? So e to the power s naught t, e to the power s naught t, and a to the power t, e to the power s naught t and a to the power t. This is a to the power t only, right? This is like a to the power t only. So both are eigen function of an LTI system. E to the power s naught t and a to the power t both are eigen function of an LTI system, and the eigen value is h s naught. So in case of e to the power s naught t, what will be the eigen value? H s naught. But in case of a to the power t, what will be the eigen value? So what you can do? E to the power ln a into t. So s naught value is ln a. So h ln a. This will be the eigen value. Okay, and eigen function is 2 to the power t only. Right? All good? Understood? So let's remove this one, and let's write down this e to the power 2t thing here. What I am writing down? E to the power 2t can be written as e to the power 2 into t, and e to the power 2 is 7.39 to the power t. So similarly, 2 to the power t can be written as e to the power ln2 t, and ln2 is roughly around 0.7, right? So 2 to the power t can be written as e to the power 0.70. 2 to the power t can be written as e to the power 0.70. So a to the power t and a to the power s naught t both are the same thing, right? But the condition should be that ln2 should be lying. What is the value of ln2? 0.7. So 0.7 should be lying in the region of convergence. So where would be 0.7? 0.7 would be somewhere here. So this is the point of ln2. So ln2 should be lying in the region of convergence, which is lying, right? ln2 is lying in the region of convergence. So all these are the eigen functions, and their eigen values are h ln2, h2 plus 3j, and in this manner, right? Let's see. For this one, let's see it. Minus 2 to the power t. So here what I will write down? E to the power ln minus 2 t. This thing is not even defined. Not defined. Basically, ln minus 2 doesn't even exist. So here also yt unpredictable. Predictable. Right? Or you can say this is not an eigen function. Not an eigen function. So the condition is, what is the condition? That a should be greater than 0. A should be greater than 0. So here 2 to the power t you are writing down. A should be greater than 0. It could be half, it could be 3 by 2, it could be 3 by 4, it could be anything, but has to be a positive value. It's not necessary that it has to be integer. It has to be a positive value. That's it. This is the required condition. Integer, non-integer, everything would work, but it has to be a positive value. Is that clear to you? Because ln a is defined only for a greater than 0. Okay. And what about this one? If I am applying alpha s1t plus beta s2t to a LTI system, to an LTI system, considering that s12 and s1 and s2 lies in the ROC of h of s. So what will be your yt? What is this? This is linear time invariant system, and linear time invariant system will follow the property of additivity and homogeneity. So if only e to the power s1t was applied, then what would be your output? H of s1 e to the power s1t. Now if I multiply here with alpha, if only this was applied, then this was your output, h s1 e to the power s1t. Now here if I multiply with alpha, so here also alpha will be multiplied. If only e to the power s2t was applied, then what would be your output? H of s2 e to the power s2t. So whatever the input was there, that will be reflected back. Now what will be the eigenvalue? Eigenvalue will be, in place of s you put s2. If I multiply beta here, so here also you will get beta. If I add both of them, then output will also be added. If I add both of them, then output will also be added. So this is the property of homogeneity, and this is the property of additivity. Homogeneity, homogeneity, additivity. Did you understand this point? So what would be the output? So here yt can be written as alpha h s1 e to the power s1t plus beta h s2 e to the power s2t. This is the yt we are getting. Okay. So here just I am telling that since it is a LTI system, so it will follow the property of additivity and homogeneity. All good? All fine? So what is the conclusion? Till this point, whatever that we have studied, that we are writing down as a conclusion. So conclusion is yt would be equals to h of s naught e to the power s naught t, where s naught could be anything. It could be real, it could be imaginary, or it could be complex. Right? But here what will be the condition on A? That it should be greater than 0. Okay. And the other thing is this A can be written as e to the power ln A t, right? E to the power ln A t. That means S naught and ln A. Look here, A should not be lying in the region of convergence. Ln A should be lying in the region of convergence. That means S naught and ln A should lie in the region of convergence of HS. So here this would be the output, and here what will be the output? H of ln A to the power t. So two outputs we will be getting. Is that clear to you? Is this discussion clear to you or not? Okay. So now this simple question is there. For an LTI system, which of these are eigenfunctions? Considering here the question is not complete, I have to consider one thing. Consider ROC entire S plane. So now I don't need to think that S naught will be lying in the region of convergence or not. So ROC is entire S plane. Okay, this is given in the question. So e to the power s naught t, yes, s naught value is 2j. So here h of 2j you will get e to the power s naught t, s naught value is -2. So this is also a eigenfunction. E to the power s naught t, s naught value is 3. So h of 3 you will get. This is your eigenvalues. E to the power 2t ut. No. Did I say ut? See the conclusion. There is nowhere ut written. E to the power s naught t, ut is not there, because if ut is there, then difference would be created. In the derivation only, in this derivation only difference would be created, because here another factor will come into action, that would be u of minus tau plus t. So that will interchange the limits and all these kind of things. Then I need to take the value of t, and based on that I need to solve. So here if ut is there, then things will be different. E to the power s naught t, everywhere what we are writing down, e to the power s naught t, everywhere what we are writing down, the applied input is e to the power 2t, e to the power minus 3t. This is the impulse response. We are not talking about impulse response. We are talking about the input. E to the power s naught t, e to the power s naught t, e to the power s naught t, e to the power s naught t. Impulse response could be anything. We don't care about the impulse response, but we are talking about the input, right? So wherever ut is written, they will not be into action. 2 to the power t, it can be written as e to the power ln 2 t. So h of ln 2. Yes, this can be written as h of ln 0.5, right? Or h of minus ln 2. You can write down h of minus ln 2. 1. This is also eigenfunction. 1 is also eigenfunction. Why is that so? Because 1 can be written as e to the power 0t. So here what is the eigenvalue? E to the power s naught t, what is the value of s naught? 0. So eigenvalue is h of 0 and eigenfunction is 1 only. Because 1 can be written as e to the power 0t, and what is 0? 0 is s naught value here. So h of s naught, h of 0. This is what you are getting. So this is also correct. This will be wrong, because what is the condition? A has to be greater than 0. Okay, so minus 1.5, this will not be an eigenfunction, considering that ROC is entire S-plane. So if ROC is entire S-plane, then e to the power S naught t, S naught t, e to the power S naught t, 2 to the power t, 0.5 t, or even 1 is also eigenfunction, but this negative value will not be an eigenfunction, and if ut is connected, then surely they will not be an eigenfunction. Is that clear to you? Right? Now, why we are studying this concept? Why we are studying the concept of eigenvalue and eigenfunction? How it will help us? How it is helping? So let's just say my xt is any periodic signal. So you know the one thing, if you have studied the chapter Fourier series, xt could be written as c naught plus c1 e to the power j omega naught t, c of minus 1 e to the power minus j omega naught t, c2 e to the power 2 omega naught t, plus c of minus 2 e to the power minus 2 omega naught t, and so on, where omega naught is the fundamental frequency, where omega naught is the fundamental frequency of xt. This we have already seen in our Fourier series, that any periodic signal can be written in terms of complex exponentials with the discrete frequencies of omega naught, 2 omega naught, 3 omega naught, 4 omega naught, and so on. This we have already seen. Now, if this is my input, if a periodic signal is my input, and what is my h of s? My h of s here is 1 upon s plus 2, 1 upon s plus 2, e to the power minus 2 t ut, with the ROC of real part of s greater than minus 2, right? So can I make the ROC? Yes, make the ROC. Real part of s greater than minus 2. So here this will be your ROC, and ROC includes the j omega axis, right? ROC is including the j omega axis. So if I say this is my c naught, right? This is my c naught. C naught is an eigenvalue or not? Sorry, c naught is an eigenfunction or not? Because c naught can be written as c naught into e to the power 0 t. And what is the value of s naught? 0, which will be lying here. For this one, c1 into e to the power j omega naught t. So c1 is a constant value, don't care. E to the power j omega naught t. What is the value of s naught? I need to compare with e to the power s naught t. And I told you homogeneity property will be followed, so c1 can be multiplied here. So what is the s naught value? S naught value is j omega naught. S naught value is j omega naught. What is the s naught value here? Minus j omega naught. What is the s naught value here? j2 omega naught. Then minus j2 omega naught. In that manner, s naught values are there, and all these values are on j omega axis, and our ROC includes the j omega axis. What I am saying, all these values are on j omega axis, and our ROC includes the j omega axis. That means all these points are lying in the region of convergence of h of s. What I mean to say is that from here, what do I see? That 0, j naught, minus j naught, 2j naught, 2j omega naught, minus 2j omega naught, and so on lies in the ROC of h of s. What does that mean? All these will become eigen function of LTI system. So what they are? All these are eigen function of LTI system. Of LTI system. So can you write down the output yt very easily? Yes, very easily I will be able to write down the output yt, because for the first one c naught will come as it is. What is the eigenvalue? Eigenvalue will be h of 0, right? And then basically, do you see this thing? C naught can be written as e to the power 0 t. So what will be the output? E to the power 0 t only. C naught is a constant value. It will be multiplied with the factor of h of s naught. What is the value of s naught? S naught value is 0. So c naught into h of 0 e to the power 0 t. E to the power 0 t is 1 only. So this is the output. For this particular thing, what will be the output? So e to the power j omega naught t. What will be the output? E to the power j omega naught t only. But it will be multiplied with the factor of h s naught. What is the value of s naught? J omega naught. And if it is multiplied with c1, this will also be multiplied with c1. So c1 h j omega naught e to the power j omega naught t plus c of minus 1 h of minus j omega naught e to the power minus j omega naught t. in the similar manner C2 h of 2j omega naught e to the power 2j omega naught t. In the same manner you can write down the output, right? So very easily you can write down the output, but the condition is that region of convergence of h of s, region of convergence of h of s, ROC should include j omega axis, because if it is not including j omega axis, then all these points will not lie in the region of convergence, then they will not be the eigen function of LTI system. So if you want them to be a eigen function of LTI system, that means in the region of convergence all these points should lie. What does that mean? That ROC should include j omega axis. And if ROC is including j omega axis, that means the system is stable, right? If ROC is including j omega axis, that means h of t is absolutely integrable, and that means system is stable. System is stable. So it's not necessary that ROC should be looking towards plus infinity only. The ROC could be somewhat like this as well. ROC could be somewhat like this as well. But the important part is it should include the j omega axis. So for a stable LTI system, if you are applying any periodic input for a stable LTI system, if you are applying any periodic input, so all the components of that periodic input will be your eigen functions. So very easily you will be able to write down the answer. Are you able to understand this point or not? So if you know the C0, C1 values, along with that you would know the fundamental frequency, so very easily you can write down the output by T. So that's why we have studied this concept of eigen value and eigen function. Is that understandable? But the condition is system has to be stable. A very important point here, system has to be stable, because if system is not stable, that means it is not including the j omega axis, and if it is not including the j omega axis, then all these points j omega naught minus j omega naught, 2j omega naught minus 2j omega naught will not lie in the region of convergence. And if they are not lying in the region of convergence, that means you cannot consider them as your eigen functions. So output will be unpredictable, or you can say output will be unbounded if your system is unstable, right? For a stable system, this will be the output. What will be the output? This will be the output for a stable system, right? So now we will understand the same scenario with respect to Fourier transform. So using the Fourier transform, now we are going to understand the eigen value and eigen function. So till this point we were doing with respect to Laplace transform. Now we will do it with respect to Fourier transform. So I will take a pause, drink some water, and then I will come back. You can also take a pause or revise whatever that we have studied. Okay, yeah, welcome back. So now we will understand the concept of eigen value and eigen function using the concept of Fourier transform, right? So do you remember when the Fourier transform is defined? Fourier transform for a particular signal ht will be defined only when ht is absolutely integrable. So ht should be absolutely integrable, then only h of omega will be defined. And what is the meaning of ht being absolutely integrable? That means ROC of h of s will include j omega axis. And what does this mean? This means that LTI system whose impulse response is ht, that is stable. Say yes or no. So your h of omega will be defined only when your LTI system is stable. So if they have given h of omega, that means 100% your LTI system is stable. Are you able to understand this point? If they are denoting a particular system with h of omega, that means you don't need to think whether the system is stable or not. 100% it will be stable, because if LTI system is stable, then h of t will be absolutely integrable, and then only h of omega is defined. So if h of omega is defined, that means ht is absolutely integrable. That means ROC of h of s will include j omega axis, and then that means LTI system is stable. So this concept is clear to you. Now let's just say they have defined h of s here. Let's just say they have defined h of s. They did not give ht, they have defined h of s. And by some analysis, you get to know that the ROC of h of s is including j omega axis. What I am saying, the block diagram is shown by h of s, not by h of omega. The block diagram is shown by h of s. Now by some analysis, you got to know that ROC of h of s includes j omega axis. That means ht is absolutely integrable. So from h of s, how will you go to h of omega? You will just put s equals to j omega. So in place of h of s, in place of s, if you put j omega, what do you get? H of omega. So two kind of things are there. First thing is that if h of omega is defined, then surely your ht is stable. Your LTI system is stable. H of omega is defined, no issue. If h of s is defined, and you get to know that ROC of h of s is including j omega axis, then from here as well you can get h of omega. But the necessary condition is ROC of h of s should include j omega axis. So the bottom line is, two bottom lines are there. One bottom line is if h of omega is defined, that means h of t is absolutely integrable, that means LTI system is stable. Now if h of s is defined, if they have given h of s, that means you need to check the region of convergence. If region of convergence is including j omega axis, that means from h of s, if you put s equals to j omega, you can get h of omega, right? And LTI system is stable. Now in the same thing here also, some input will be there, that would be x of omega, and some output would be there, that would be y of omega, and that would be given as x of omega dot h of omega. So here also we will see some question. The question is, the applied input is e to the power j omega naught t, what will be your output yt? Okay, applied input is e to the power j omega naught t, what will be your output yt? They are saying that LTI system is stable, and if it is stable, what does that mean? That means I can define h of omega for this particular thing. So let's find out yt. So by the basic definition, I know that yt can be given as h of tau as it is. Basically yt can be given as ht convolution with xt, convolution with ht. So one as it is, other one inverted and then shifted, right? So let's keep h of tau as it is. This one inverted and shifted, e to the power j omega naught, it was really, sorry, e to the power j omega naught is, it was inverted and then shifted. So what you can see, e to the power j omega naught t will come outward, e to the power j omega naught t will come outward, h of tau e to the power minus j omega naught tau d tau. What do you remember? What is your h of omega? H of omega is given as minus infinity to infinity ht e to the power minus j omega t dt, right? In place of omega, what I am doing? I am putting omega naught, and in place of t, what I am putting? Look, omega I am putting as omega naught. Omega I am putting as omega naught, and in place of t, I am putting tau. So h of omega naught will be given as minus infinity to infinity h of tau e to the power minus j omega naught tau d tau. So this is equivalent to h of omega naught. So what you are getting? Yt as h of omega naught e to the power j omega naught t. So what is the yt you are getting? So yt you are getting, whatever the input is there here, whatever the input is there, that is reflected back here. If I write down the yt, whatever the input is there, that is coming similar at the output. Along with that, here in place of omega, you are putting omega naught e to the power j omega naught t. And will there be any condition? Will there be any condition that this j omega naught should be lying in the region of convergence or anything? No, because for h of omega there is no region of convergence. H of omega will be defined only when the ROC includes j omega axis. So if it is defined, then you don't need to think. What I am saying, for a particular system, they have defined h of omega, and your input is e to the power j omega naught t. So now you don't need to think anything. Directly put omega naught and the answer will be correct. But in case of h of s, if you are putting s naught, at that time you are thinking that s naught should lie in the region of convergence. But here h of omega will be defined only when this j omega naught should be lying in the region of convergence. Because if h of omega is defined, that means ROC includes j omega axis. That means surely this j omega naught minus j omega naught or plus j 2 omega naught or minus j omega naught or anything, these will surely be in the region of convergence for sure. Then only h of omega will be defined. So the bottom line is, if h of omega is defined, that means surely e to the power j omega naught t will be your eigen function, right? So e to the power j omega naught t will surely be your eigen function. It will be your eigen function. Okay, and this is your eigenvalue. But what is the condition? Condition is that h of omega should be defined. Condition is h of omega should be defined, and if h of omega is defined, that means LTI system is stable. So if your LTI system is stable, then surely e to the power j omega naught t will be one of the eigenfunction. So e to the power j omega naught t will surely be eigenfunction if your LTI system is stable. If I am saying that ht is stable, if I am saying ht is stable, what does that mean? That the region of convergence of h of s will include j omega axis. It will include j omega axis, and if it is including the j omega axis, that means j omega naught or j2 omega naught or anything will surely lie in the region of convergence. If they are lying in the region of convergence, then surely it is a eigenfunction. Okay, so this is the conclusion, that e to the power j omega naught t will surely be a eigenfunction of a stable LTI system. Okay, so you can write down this line anywhere, that e to the power j omega naught t will surely be a eigenfunction of a stable LTI system. That's it. Okay, let's go to this analysis. So this is the conclusion, e to the power j omega naught t. So what will happen? What will be your output yt? E to the power j omega naught t will only be reflected, but in place of omega, what you will put? Omega naught. Right? This is the output. This is how the output yt will be given. So now this is how your h of omega is defined. This is how your h of omega is defined. This is not h of s. This is h of omega. So if h of omega is defined, that means by default you know that ROC will be including j omega axis. So from here, what you need to pick? Will you pick 3j? No. Omega value is 3 only. No. Omega naught value is 3. Omega naught value is 3. So you need to write down 3 here. So what will be your yt? 1 upon 3j plus 2 e to the power j3t. Basically, it would have been defined in this manner. In this manner as well. It could have been defined in this manner as well. What I am saying? 1 upon s plus 2. But you need to say that region of convergence is greater than minus 2. Because if it is less than minus 2, if your region of convergence was less than minus 2, then ROC would not include j omega axis. If your region of convergence was less than minus 2, then ROC would not include j omega axis. But if it is greater than minus 2, then it is including the j omega axis. So this is also how you can define it. Now this is your h of s. What is the applied input? Applied input is e to the power j3t. E to the power j3t. Now this is also how you can write down the output. Now what you will say? What is the s naught value here? S naught value is 3j. S naught value is 3j. So this S naught value I will write down here. 1 upon 3j plus 2 e to the power j 3t will come as it is. So in both of the cases you are getting the same answer only. Are you able to understand this point? If you are solving with respect to h of omega, that means by default you know that your ROC includes j omega axis. Then directly in place of omega you need to put the omega naught value. This omega naught value you need to put here and you will get your answer. Okay. Now cos omega naught t. What will be the output yt if the applied input is cos omega naught t? So this is a very good question. Okay. So this is your LTI system which is defined by h of omega. What does that mean? That means LTI system is stable. So from here I know that LTI system is stable. Only conclusion is LTI system is stable. It is causal or anything, nothing is there. Causal, even, odd, nothing is there. Only point is LTI system is stable, nothing else. Stable. Causal, even, odd, nothing. Only LTI system is stable. So if LTI system is stable, what is the applied input? Applied input is e to the power j omega naught t plus e to the power minus j omega naught t divided by 2 and then divided by 2. So what will be the output? So output yt will be, if applied input was e to the power j omega naught t, if applied input was e to the power j omega naught t, then output would have been h of omega naught e to the power j omega naught t. If I divide by 2, here also it will be divided by 2. If the applied input was this thing, then the output would have been e to the power minus j omega naught t divided by 2 and then divided by 2. If both are added, then this will also be added. So what you are getting? H of omega naught by 2 e to the power j omega naught t plus h of minus omega naught 2 e to the power minus j omega naught t. So this will be the output. Are you able to understand this point? So this is the output you will be getting. This is the output yt you will be getting. So can you say that cos omega naught t is an eigen function? Are you getting yt as some constant value into cos omega naught t? No. This is not what you are getting. Surely you are not getting it. Are you able to take this h omega naught common? If I was able to make this common, let's just say if h of omega naught was equal to h of minus omega naught. So what I could have done, I could have take this common, then here I would have got this particular thing, right? And then I could have said that h of omega naught into cos omega naught t. Then I could have said that my cos omega naught t is my eigen function. But here there is nothing like that. Here what I am saying, that my h of omega naught is not equals to h of minus omega naught. And that's why I cannot write down my yt as k cos omega naught t. That means my output is not the amplified factor of cos omega naught t. Basically, output is not equals to cos omega naught t multiplied with any factor. So no, it is not equals to that. That means cos omega naught t is not an eigen function of this LTI system, of a stable LTI system, So what do you need? You need that. So directly if someone says that h of omega is defined, that means ht is stable. So cos omega naught t, will that be an eigen function of the LTI system? You will say no. Cos omega naught t is not an eigen function of a LTI system. So when it can be a eigen function? When h of omega naught is equals to h of minus omega naught. So if h of omega naught is equals to h of minus omega naught, and that I am calling as h of omega naught only. So what I will write down, my yt will be, here h of omega naught will come common, e to the power j omega naught t plus e to the power minus j omega naught t divided by 2. So now you are getting your yt as h of omega naught cos omega naught t, right? And what is this? This is your eigen value, and this is your eigen function. So first thing is that LTI system has to be stable, because if it is not stable, then there is no meaning of this j omega and minus j omega naught. Because if LTI system is not stable, that means ROC doesn't include j omega axis, and if ROC is not including j omega axis, that means this j omega naught and minus j omega naught you will never be able to put here. So if you want to put these values, that means system has to be stable. Along with that, h omega naught and h of minus omega naught should be equal. So what is the condition? Cos omega naught t will be an eigen function of an stable LTI system only when h of omega naught is equals to h of minus omega naught. But e to the power j omega naught t will always be an eigen function, of a stable LTI system. Why I am writing n? Of a stable LTI system. And what is the meaning of stable LTI system? That means h of omega is defined. So if h of omega is defined, then you can close your eyes and you can say that e to the power j omega naught t is my eigen function. But in case of cos omega naught t, you cannot close your eyes. You have to say that I will close my eyes only when h of omega naught is equals to h of minus omega naught. So what does that mean? ht should be even, right? Because if ht is even, that means h of t will be equals to h of minus t. That means h of omega should be equals to h of minus omega. So h of omega naught will be equals to h of minus omega naught. So if ht is even, then your job is done. But is it the only condition? ht has to be even. No, what I mean to say is that, let's just say this kind of a h of omega graph is somewhat like this. H of omega graph is somewhat like this. I just say this is 1, this is 2, this point is also 2. So this point is 1.5. Okay, and this point is -1, this point is -2, and this point is 1. So this is how the graph of h of omega is made. Okay, this is the graph of h of omega. 1 I should make downward. So this is the point which is 1. So this is the graph of h of omega. Is this even? No. But I am saying that my applied input is cos 1.5t. That means what is the value of omega naught? 1.5. Now from this graph, what is h of 1.5? So here the slope is 1, so this point will be also 1 only. Here the slope is 2. If you are going from 1 to 2, that means you are increasing by 2. So if you go from 1 to 1.5, that means you will increase by 1. So h of 1.5 is 1. H of minus 1.5 is also 1 only. So now h of omega is equals to h of minus omega naught. H of omega is equals to h of minus omega naught. H of omega naught is equals to h of minus omega naught. That means this cos 1.5t will be a eigen function for this particular LTI system. But this particular LTI system is not even. H of t is not even, because if h of omega is not even, that means h of t is also not even. So even is not the only condition. Like even is not the necessary condition. If it is even, then surely it will be, surely cos of omega naught t will be a eigen function if h of t is even. But it doesn't mean that h of t has to be even. No, h of t necessarily not need to be even. Okay, so this question have been framed from my side in this particular lecture only, so you will understand that. I hope you have understood here only, right? So only condition is that h of omega should be equals to h of minus omega naught. H of omega naught should be equals to h of minus omega naught. I am not saying that h of omega should be equals to h of minus omega. No, this is not the desirable condition. Only required condition is h of omega naught should be equals to h of minus omega naught, right? So same goes for sinusoid as well, but here I have written one thing, that e to the power j omega naught t will surely be an eigen function. Impulse response of LTI system is xt. Given that LTI system is stable, so which of the correct statement is there, that e to the power j omega naught t will surely be an eigen function? Yes. Cos omega naught t and sin omega naught t. Same goes for sin omega naught t as well. Here also we can do the same analysis for sin omega naught t. What will be your yt? Your yt will be here. What will happen? E to the power j omega naught t. So omega naught will be copied here. What you will get? H of omega naught. Then whatever the input is there, e to the power j omega naught t. If this is divided by 2j, so this will also be divided by 2j. And then there is a negative sign, so negative sign would come. So here what you will put? Minus omega naught. So h of minus omega naught. Then whatever that is the input, the same input is there. If it is divided by 2j, so it will also be divided by 2j. So this is the output yt you are getting. Now if h of omega naught is equals to h of minus omega naught, then what will happen? This I am calling as h of omega naught only. Then what will happen? H of omega naught I can take common, and here what I will be left with? E to the power j omega naught t minus e to the power minus j omega naught t divided by 2j. So what you are getting? H of omega naught sin omega naught t. So this is the answer yt you are getting. So your answer yt is h of omega naught sin omega naught t. But with the condition, this is the condition. Otherwise, what is the output? This is the output. So similar thing, whatever that I have written for cosinusoid, here sin omega naught t, here I can write down sin omega naught t and cos omega naught t will be a eigen function of a stable LTI system only when h of omega naught is equal to h of minus omega naught. But e to the power j omega naught t will surely be a eigen function of a stable LTI system. So what is given? Stable it is. So e to the power j omega naught t will surely be a eigen function. Cos omega naught t and sin omega naught t will surely be eigen function? No. Cos omega naught t and sin omega naught t will be an eigen function if h of t is even. Because if h of t is even, or let's do it on the next page. Because if h of t is even, then h of t will be equals to h of minus t. Now what is the Fourier transform of ht? That is h of omega. What is the Fourier transform of h of minus t? That is h of minus omega. Now at omega equals to omega naught, h of omega naught will be equals to h of minus omega naught. So yes. So if it is even, then it will do the job. But it has to be even? No, because I told you one scenario where only at omega naught you need to get the same value. It is not necessary that it has to be even. If someone is saying that at omega naught and minus omega naught the frequency spectrum is throwing the same value, then surely your cos omega naught t and sin omega naught t will be eigenfunction, otherwise they will not be. Now cos omega naught t and sin omega naught t will be the eigenfunction if h of omega naught is equals to h of minus omega naught, and here only word could also be written, only if, only if. So here only word will also be written, because this is the necessary condition, this has to be there. Okay, this is one of the good condition that if it is there, then we will be sure that it will be a eigenfunction. But this is the necessary condition, it has to be there, right? So I hope you understood this particular true or false. So these are important ones. Okay, these are some good questions which can be asked from eigenvalue and eigenfunction. So now if there is a phase, okay, previously what we were applying, cos omega naught t we were applying. Now what if there is a phase, there is a phase phi? So what will happen? Nothing will happen, same output you will be getting. What I mean to say is that if there is a phase phi, so what kind of input will be there? How I can write it down? E to the power j omega naught t, let's call it theta. So what will be your cos theta? E to the power j theta plus e to the power minus j theta divided by 2, right? So e to the power j omega naught t plus phi plus e to the power minus j omega naught t plus phi divided by 2. So this can be written as e to the power j phi. So e to the power j phi will be a constant value, right? E to the power j phi is, let's just say, pi by 3. So this is not a function of t, it will be a constant value divided by 2. So this will become a constant value. So e to the power j phi divided by 2 e to the power j omega naught t plus e to the power minus j phi divided by 2 e to the power minus j omega naught t, and here h of omega naught is there. So what will be your yt? Yt will be whatever the constant value is there, that comes as it is. You know that e to the power j omega naught t is eigenfunction, plus whatever the constant value is there, that comes as it is. You know that h of minus omega naught is a eigenfunction. So there you go, very easily you can write down this answer. Now if h of omega is equals to h of minus omega naught, and that I am calling as h of omega naught, so what would be your yt? Your yt would be h of omega naught can come common, right? Inside what can go? E to the power j omega naught t plus phi plus e to the power j omega naught t plus phi divided by 2, right? Here h of omega naught coming common, this part came common, rest all the part e to the power j phi plus omega naught t e to the power minus j phi plus omega naught t. So what you are getting? Yt as h of omega naught, what this would be? Cos omega naught t plus phi. So there you go. Okay, but this is only there for this particular case, otherwise what would be the output? Otherwise this would have been the output. So nothing is changing. Even if there is a phase, then don't worry, phase is there, then all the concept whatever that we have written down for sin omega naught t and cos omega naught t, same goes here as well, that cos omega naught t plus phi will be an eigenfunction of an LTI system, of a stable LTI system. Again h of omega is defined, that means stable LTI system, of an stable LTI system only when h of omega naught is equals to h of minus omega naught. Okay, otherwise this is how we will write down the output. Same goes for sinusoid as well. So what will be the output of sinusoid? H of omega naught divided by 2j e to the power j phi e to the power j omega naught t. Do you agree to this point? Then there will be minus sign, h of minus omega naught divided by 2j e to the power minus j phi e to the power minus j omega naught t. I hope you are able to relate it. Whatever the analysis that I did here, the same analysis I am doing here, just the extra phase is coming, and if your h of omega naught is equals to h of minus omega naught, and that I am writing down as h of omega naught, then what will be the yt we will be getting? H of omega naught into cos omega naught t plus phi. So this thing you will be able to do only when this is the condition. So if this is the condition, then directly what you can do, you can pick this omega naught and put it here. But we are not going to show it in the diagram because always it is not true. Now, a very good point. If h of t is real and absolutely integrable, that means ht is stable and real. If ht is real, or what it can be written, that your LTI system is, from this statement what do you understand? The ht is real and absolutely integrable. So from here you can say that your LTI system is real and stable. If your LTI system is real and stable, which are the practical scenario, like any RC circuit or RL circuit, like practically realizable system will be always real. Will it be stable? That is up to the designer. If it is stable or not, that is up to the designer. But practically realizable systems will always be real, right? And h of omega naught is not equal to h of minus omega naught. So how you can write down your output yt? So output yt can be written as h of omega naught e to the power j omega naught t e to the power j phi plus h of minus omega naught e to the power j omega naught t e to the power minus j phi divided by 2, right? Divided by 2, everywhere divided by 2. Now for now what I am doing, this 2 I am taking here, I can multiply here, right? This 2 I can multiply here. Now I am saying that ht is real. ht is, this I am calling as equation 1. Arey yaar, this I am calling as equation 1. ht is real. Now if ht is real, do you remember anything about the frequency spectrum? I hope you remember it. If ht was real, what did I tell you? That your frequency spectrum, magnitude spectrum will be even. And for the phase spectrum can never be even or odd. Phase spectrum can be defined in this manner. Will be equals to 2n pi. Do you remember this particular thing? If your ht is real, then your magnitude spectrum will be even. And phase spectrum will have this relation. That for positive frequency and for negative frequency, if you add up the phase, then both adding up the phase should be equals to 2n pi, where n belongs to any integer. That means this phase would either be 0 or plus minus 2 pi. The addition of the phase would be either 0 or plus minus 2 pi or plus minus 4 pi or so on. You cannot say it would be odd. Phase spectrum is odd. I told you for phase spectrum there is nothing called even or odd. Phase spectrum could be anything. It could be even or odd, anything. Right? So for the phase spectrum, this was the relation. So if ht was real, then these two things we defined. Say yes or no. Well and good. So now how your h of omega can be written? H of omega naught can be written as mod of h of omega naught and then the angle of h of omega naught, right? And how this h of minus omega naught can be written? That mod of h of minus omega naught and then angle of h of minus omega naught. Now this mod of h of minus omega naught is equal to this thing. From here we can see this, if I call as equation 2. So from equation 2 what I can see is that this is how I can write it down. And from equation 2 what will be the value of this one? What will be the value of angle of h of minus omega naught? That would be equal to 2n pi minus angle of h of omega naught. So here j, here what I can write down? 2n pi minus angle of h of omega naught. Do you agree to this point? H of omega naught is written like this. I am not doing anything with that. H of minus omega naught is written like this. Now mod of h of minus omega naught is equal to mod of h of omega naught. And the angle could be written as e to the power j 2n pi minus angle of h of omega naught. So what we are getting? H of minus omega naught as mod of h of omega naught e to the power j 2n pi e to the power minus j angle of h of omega naught. What is the value of this one? E to the power j 2n pi? 1, right? Always it is 1. So what did you get to know? That your h of omega naught was mod of h of omega naught e to the power j mod of h of omega naught e to the power j angle of h of omega naught. This was already there. Now what is this coming out to be? This is coming out to be, oh sorry, this is coming out to be, because these modes were equal, then e to the power minus j angle of h of omega naught. And all these are coming when ht is real. Ht has to be real. Now what we can do, in the equation 1 we can put these values. So from equation 1, ht is real. This is very necessary condition. Ht is real, then only all these things are coming into action. So what I can see, 2yt is equals to mode of, in place of h of omega naught, what I am putting, mode of h of omega naught, then e to the power j omega naught t plus e to the power j phi is already there. So e to the power j omega naught t plus phi. Along with that, this angle will also come. You agree to this point? Plus, here what do you see? Mode of h of omega naught e to the power minus j. Just 1 second. Here it was minus, sorry. Here it was minus. So e to the power minus j omega naught t plus phi, e to the power minus j omega naught t plus phi, plus this negative angle will also come. But already minus sign is taken common. So here what I can write down? Say yes or no. Do you agree to this point? So what you can see here, mode of h of omega naught, if I take common, then this 2 I am taking downward now, divided by 2. This 2 will go here. What I can see, e to the power j theta plus e to the power minus j theta divided by 2. E to the power j theta plus e to the power minus j theta divided by 2. Where what is theta? Omega naught t plus phi plus angle of h of omega naught. So what you are getting your yt as, that mode of h of omega naught cos omega naught t plus phi plus angle of h of omega naught. There you go. This is your yt. Considering that, considering what, h of t is real and surely it has to be stable, because if it is not stable then there is no meaning of a eigenvalue and eigenfunction. So considering that ht is real and stable, this is your output. Yt can be defined if your applied input is cos omega naught t plus phi and it was multiplied with a as well. So let's remove this a. Basically, for any input, if your output is yt, for any input in a LTI system, if your output is yt, so if I multiply a into xt, so what will be output? A into yt. So whatever the output that you have written, that will be multiplied with a. So don't worry about this a. This a is a constant value. That will also come into action. So what did you understand? Same goes for cosinusoid as well. Okay. But here we should write down the conclusion. What we should do, we should write down the conclusion. So for that we need to add a page. So what is the conclusion? What does the conclusion say? That here ht is real and stable. Since it is stable, then h of omega will be defined. Now if your applied input is, same goes for sinusoid as well. So for sinusoid, okay, so this slide I can cancel out. So if your applied input is a cos omega naught t plus phi, so what you will do, it is real, just as you have seen real. What you will do, you will find out the value of h of omega naught. You will find out the value of h of omega naught. So h of omega naught will have some magnitude and it will have some phase as well. It will have some phase as well. So what you will do, how will you write down your output yt? Your output you will write down yt as whatever the magnitude was there, that you will multiply. Just 1 second guys. Yeah, so what I was saying, whatever the magnitude was there for h of omega naught, whatever the magnitude was there, that you will multiply. And then in the phase of cos, cos omega naught t plus phi, in the phase of cos, another phase you will introduce, that is this one. Now does that mean that it is an eigenfunction? Does that mean it is an eigenfunction? No, no, no. Don't confuse it with the eigenfunction. If I say ht is real and stable, so will you say that this is an eigenfunction, a cos omega naught t plus phi? If it was an eigenfunction, then some constant value and then cos omega naught t plus phi should have come, but another phase is coming, no? So this is not an eigenfunction. This is just a shortcut we have created, that if your ht is real and stable, then I can directly write down my yt without doing which calculation, without doing this calculation, without doing these kind of calculation, without doing this calculation, I will be directly able to write down my output yt if my ht is real and stable. Are you able to understand this point? So that's why we did this calculation. It is not we are surely not saying that your yt is equals to some constant value cos omega naught t plus phi. No. If this was the condition, then only you could have said that yes, that this is your eigenfunction. But no, this is not an eigenfunction, not an eigenfunction. So all these calculation we are only doing just to reduce our calculation, nothing else, not an eigenfunction. So if these kind of questions are coming, that ht is causal and real LTI system, better than that, I am not saying it is causal. Okay, what I am saying, better than that, I am defining its ROC, which is real part of s greater than -2. So now you understand on your own what is your ht. What would be your ht? ht would be e to the power -2t ut. So will you do the convolution now? 3 cos 2t plus pi by 6 convolved with e to the power -2t ut, and then you will find out the output yt. No. What did you see here? That sir, it is real. And what is the ROC? Real part of s greater than -2. That means it is stable as well. So it is real and stable. And sir, if it is real and stable, I know one thing, that I just need to find the value of h of omega naught. So will my omega naught will be this, that omega naught, what is the value of omega naught here? Omega naught value is 2. So 2 plus 2. No, no, no. This is your h of s. What will be your h of omega? H of omega you will get when you put s equals to j omega. So 1 upon j omega plus 2. If it is stable, that means it includes the j omega axis, and if it is including the j omega axis, then with the help of h of s you can find out h of omega. So first I found out my h of omega. So my h of omega is 1 upon j omega plus 2, and here what is the value of omega naught? Omega naught value is 2. So what will be my h of omega naught? That would be 1 upon 2j plus 2. And why I am finding out all these things? Because one thing I would be needing, that will be the magnitude, which will be 1 by 2 root 2. You know how to find out the magnitude? J plus 1, 2 root 2. So magnitude is 1 upon 2 root 2. And what is the angle? What is the angle? Angle will be minus tan inverse y by x. So minus 45. Or you can say minus pi by 4. Right? So all these things in basics of complex variable we have understood. This was our first lecture, basics of complex variable in network analysis. So there we have understood how to write down these angles and these magnitudes. Right? So magnitude is 1 by 2 root 2 and angle is minus pi by 4. So now what will be your output yt? So output yt will simply be whatever the constant factor is there, 3 is there. Now this constant factor in the magnitude, it will be multiplied with h of omega naught. So it will be multiplied with 1 by 2 root 2. Then whatever cos is there, same will come. 2t plus pi by 6. 2t plus pi by 6. Just another phase will be subtracted, which is pi by 4. So what we will be getting? 3 by 2 root 2 cos 2t minus pi by 3. Right? Because this is, no. This is your 30. No, this is 60. 180 by 6. 30 minus 45 minus 15. So this will be minus 15. Why I am writing down? Pi by 6 minus pi by 4. 24, 4, 6 minus pi by 12. So this will be minus pi by 12. Okay, so this is the answer you will be getting. This is your final yt. So very easily you would have written down this output yt. And in network analysis, whenever a RC circuit is exposed to a cosinusoid or sinusoid input, you do the same analysis. And then you tell that this is a steady state response. There will be one transient response as well. And then you introduce that transient response as well. So that thing we do in the network analysis. But in network analysis, I directly tell you this result. That directly, if this is applied, then this will be the result, that you find out the transfer function, and in the transfer function, in place of s you put j omega naught, and from there you get the magnitude, and the angle, and magnitude you multiply and angle you add here. So what was the angle we were getting? Minus pi by 4, that was added here. Minus pi by 4 angle was added. So this is the answer we are getting. Okay. Same thing will go for sinusoid as well. So you write down the output of a sinusoid. What that would be? H of omega naught sine omega naught t plus phi plus angle of h of omega naught. There you go. This is how you will write down the output. A into magnitude, from here you will get h of omega at omega naught. So here your h of omega naught will be magnitude of h of omega naught and angle of h of omega naught. So same goes for sinusoid as well. Well and good. Now we will solve this question. So this particular question is there. H of omega is made. That means surely ht is stable. This is the xt. You need to find out the output yt, and after that you need to tell which of the following statement is true. So these 4 statements are written. Which of them is or are true, that you need to tell. So first solve this question on your own. You need to solve this question on your own. I will take a pause because it's been around 45 minutes. So I will take a pause and then we will solve this question. Okay. So take up, do it on your own and tell me which of the statement is true or false. Okay. Yeah, welcome back. So did you try this question? What was your answer of yt? So what we need to find? First we need to find yt. Now let's just say I don't even know the concept of eigenvalue or eigenfunction. I don't even know anything. So by the concept of Fourier transform, how would you solve this question? Forget about eigenfunction, eigenvalue. By the concept of Fourier transform, if I only know the Fourier transform, because in Fourier transform as well, we have solved these kind of questions, right? Because there we know that our y of omega will be x of omega into h of omega. So these are the filter response. Here h of omega is a filter. This kind of filter is there. So how I would have solved it? That I would make the frequency spectrum of x of omega. I can see that x of omega is x of t is periodic, which is having a DC and sinusoid and cosinusoid. So I will get the impulses in x of omega. So what I would have done in the examination, I would not go thinking about eigenvalue or eigenfunction. I would have simply drawn x of omega. Simply you would have drawn x of omega. You know that there is a DC. I don't care about the amplitude, but I know that at omega equals to 0 there will be one impulse. Then you know that there are sinusoids, there are cosinusoid and sinusoid. Sinusoid is there at 3 by 2 frequency at omega equals to 3 by 2. Cosinusoid is there at omega equals to 3 by 2. I don't care about the amplitude at all. So similarly at minus 3 by 2 as well, I will get another impulse. And your sinusoid is there at 3.5. Sinusoid is there at 3.5. I don't care about the amplitude at all because I know that amplitude will be multiplied now. So amplitude will be multiplied. So whatever the amplitude is there, I don't care. Let's just say this was having amplitude of alpha and this was having amplitude of beta and this was having amplitude of gamma, right? Now it will be multiplied with h of omega. It will be multiplied with h of omega. So, so at omega equals to 0, h of omega is throwing 0. That means the value of h of omega at omega equals to 0 is 0 only. So this will be multiplied with 0. Now your alpha will be multiplied with what? At 1.5. At 1.5. What it is throwing? It is throwing 0.5 value, right? Because here the slope is 1. If you are going from 1 to 2, it is rising by 1. So if you go from 1 to 1.5, it will rise by 0.5. So it is throwing 0.5 value. So this impulse will be multiplied with 1 by 2 and this impulse will be multiplied with 1 by 2. And what about this sinusoid? That is at 3.5. So this impulse at 3.5 and at minus 3.5. At 3.5 and at minus 3.5. Sinusoid is there at 3.5 and at minus 3.5. At 3.5 and at minus 3.5. So at 3.5 you are multiplying with minus 1. At minus 3.5 you are multiplying with minus 1. So this impulse will be multiplied with minus 1 and this will also be multiplied with minus 1. That means DC will be multiplied with 0. So what yt will have? So in the xt, DC will be multiplied with 0. That means DC component is gone. Cosinusoid is being multiplied with 0.5. So here the amplitude was 2. So now the amplitude will become 2 into 0.5, 1. So cos, which was there at 3 by 2. And whatever the phase is there, I don't care. The phase remains the same. Actually, I used to write down the phase as well. But what I can see is that this is not giving me any phase. At 3 by 2 you are getting the 0 phase. At minus 3 by 2 you are getting the 0 phase. Here you are getting the pi phase. Here what I could have written, instead of writing minus 1, I could have written e to the power j pi as well. But here I am only talking in terms of magnitude. If there was some different phase, then I could have written the phase as well. These kind of problems we have already seen in a Fourier transform. So as of now, I am just telling that in the examination hall, what may click to you. If this method is clicking to you, then this is how you will be solving it. And and sinusoid, no change in the amplitude, only it is multiplied with minus 1. So here minus 1 will come. So minus 3 sine 3.5t plus pi by 6. 3.5t plus pi by 6. 3.5t plus pi by 6. So this is the output yt you will get. There you go. So this is how I could have solved it in the examination. Right? But if you want to solve it with the concept of eigenvalue and eigenfunction, then how will you solve it? If you want to solve it with the concept of eigenvalue and eigenfunction. So let's solve it in that manner. So this is an LTI system. This should be given in the question that this is an LTI system. So I can treat the input separately, that first 3 is applied, then this is applied, and then this is applied. What I mean to say is that since this is an LTI system, so I can treat the inputs separately. That first 3 is applied, then cosinusoid is applied, and then sinusoid is applied. And all are defined with h of omega. H of omega and h of omega. What is the input applied? First 3 is applied, right? 3 is applied. So 3 can be written as e to the power j omega naught t. So what would be the output? Output will be h of omega naught value 0 e to the power 3 into e to the power j 0 t. What is the value of h of 0? That is 0 only. Right? Next, what is the input? Next input is 2 cos 3 by 2t plus pi by 3. 2 cos 3 by 2t plus pi by 3. Now, whenever the applied input is cosinusoid, you should be caring about one thing, that if ht is real or not. Actually, first I should not be checking about ht real or not. Here I directly checked in this particular question. Why I directly checked that ht is real or not? Actually, I should not be checking that particular thing. First, I should be checking that what is the value of h of omega naught and what is the value of h of minus omega naught. Because if both of them are equal, then my job is very easy, no? I can simply take h of omega naught outward and then I can write down my output. So here also I should have first checked that what is the value of h of omega naught, that is 1 plus j2 plus 2. And what is the value of h of minus omega naught, that is 1 plus, in place of j omega you will put minus j omega naught, that would be minus 2j plus 2. So both are not equal. Here both are not equal. So if both are not equal, then I would have gone to this analysis that if your ht is real and stable or not. So first I need to check if h of omega naught is equal to h of minus omega naught or not. If they are equal, then my job is done. Right? Why my job is done? Because if they are equal, here they are equal, right? What is the value of omega naught here? 3 by 2. What is the value of omega naught here? 3.5. So here what is the value of omega naught? Omega naught is 3 by 2. So if I check at h of 3 by 2 and h of minus 3 by 2, both are same. Both are same as 0.5. So if both are same, then my job is done. Why my job is done? How you can say your job is done? Because now cos 2 cos 3 by 2t plus pi by 3 will become an eigen function. So what will be the output you will be getting here? H of 3 by 2, which is 0.5 only. So the output you are getting is 0.5 into whatever the input that you are having, because it has become an eigen function now. This has become an eigen function because both are equal. So this is the output you are getting. So cos 3 by 2t plus pi by 3. If they were not equal, then the second thing I would have checked that if ht is real or not. So just let me know from this particular graph if ht is real or not. Here what I can see, that your magnitude spectrum is not even. Look closely, it is not even. If you see here, this is from 3 to 5, but this is from minus 3 to minus 4. So magnitude spectrum is not even. Magnitude spectrum is not even. And if magnitude spectrum is not even, what does that mean? That HT cannot be real or imaginary both. HT has to be complex. Because for real as well and for imaginary as well, magnitude spectrum will be even only. But if it is not even, that means HT has to be complex. So here first statement, HT is real, wrong. H of omega is even? No. H of omega is also not even. H of omega is also not even. What does that mean? That HT is not even. Look, all these things we have discussed in a very good detail in Fourier transform. So I hope you are able to remember everything. If magnitude spectrum is even, that means HT is real. But if complete H of omega is even, that means HT is even. But now this is not even. You are not getting it as even, right? Let's see this one. Let's come back to our question. Here I just went on some other question. Now the third type of input is 3 sine 3.5t plus pi by 6. 3 sine 3.5t plus pi by 6. Okay, so always my first task would be to check at h of omega naught. So h of 3.5 and h of minus 3.5, I can directly see that both are equals to minus 1. Both are equals to minus 1. So both are equals to minus 1. So what will happen? This value will be multiplied with minus 1. So minus 3 sine 3.5t plus pi by 6. So 0 plus this value will be your output, because they are the LTI system. If they are added here, then they will also be added here. So what will be your output yt? 0 plus cos 3 by 2t plus pi by 3 minus 3 sine 3.5t plus pi by 6. So this is the output we are getting. Let's use a different color of pen. This is the output we are getting, yt. Okay, so this is also I could have solved it by the concept of eigenvalue and eigenfunction. And here I have proved that even if HT is not even, HT is not even, H of omega is not even, still these are my eigenfunctions. Now you let me know if xt is your eigenfunction or not. Xt is your eigenfunction or not, because here what is the third statement? That xt is the eigenfunction of LTI system. Because if xt was an eigenfunction, if xt was an eigenfunction, my output should have been, yt should have been some constant value into xt. Are we getting it? No. Is our output yt some constant value into xt? Absolutely no, because xt is having a dc value. So in the output as well dc value should have come. In the output as well dc value should have come, but there is no dc value here. What does that mean? That means surely this is not a eigenfunction. But now you are defining another new signal, which is pt. Pt is given as xt minus 3. So pt is given as 2 cos 3 by 2t plus pi by 3 plus 3 sine 3.5t plus pi by 6. So this is the pt we are having, right? So if it was an eigenfunction, then output would have been k dot pt. So whatever the factor this guy is multiplied, whatever the factor this cos is multiplied, with the same factor sinusoid has to be multiplied as well, no? Basically what I mean to say is that from here I should be able to get xt. If I take something common, I should be able to get xt. Let's just say here it was plus 3 by 2. So what I would have done? I would have taken 1 by 2 common, and then inside what I would have got? This thing I would have got. But actually this is not plus 3 by 2. Here what is the answer you are getting? Minus 3 sine 3.5t plus pi by 6. So basically you cannot write your yt as k dot pt. Here also you cannot write down your yt as k dot xt. So neither pt nor xt is your eigenfunction. Are you able to understand this point? That I should be able to take out some constant value out of it, such that my yt becomes a constant value into pt. So this is your PT. Now can you multiply any constant value with this PT such that you get a YT? No. If I multiply 1 by 2, so this term I will get, but here I will get 3 by 2. But here I should get minus 3. So there is no k possible. There is no such k possible which will make k dot pt as yt. And from here, what do you understand? That pt is also not an eigenfunction. So none of them is true. So this is the end of our eigenvalue and eigenfunction. Now we will discuss another question, one more question. Did you understand this question? If you are solving with the concept of Fourier transform only, you don't know what is eigenvalue, eigenfunction, this is how you would have solved it. Within seconds, you will be able to tell the answer. In the examination, I would not even have made this particular thing. I would see that, okay, 3 by 2, what I am getting, 0.5, 0.5. 3.5 minus 1, minus 1. Okay, this will be multiplied with minus 1, this will be multiplied with 0.5. And DC value multiplied with 0. There you go. Then this I could have seen very easily. If I have the output, then very easily I could have told the answer. If you want to solve it with respect to eigenvalue and eigenfunction, so first thing you need to check h of omega naught and h of minus omega naught. Luckily, we got that both are equal only in both of the cases, so very easily I can write down my answer. So this is the answer I am getting. Okay, and then eigenvalue, eigenfunction, you already know that you should be able to take out some constant value outward, which you are not able to take out. That means both are not the eigenfunction of LTI system. The problem is coming because of this DC, along with that different gain. Here you are getting a gain of 0.5, but here you are getting a gain of minus 1. So because of that, these problems are coming. Now this question was asked in GATE 125. Okay, in instrumentation question paper, and I did not notice this particular question actually when the question paper came, because in instrumentation there are lesser aspirants. This is the sad reality, but this is the actual reality as well, that in instrumentation lesser aspirants are there. That's why educators are less serious about instrumentation, and I am also one of those guys. From now onwards, I will be more serious about instrumentation. Okay, I should have checked this question. So this question was there, and the answer given by IITs were this A and C. And surely if you solve this question, you will say that, sir, this is not the answer. A is for sure answer. So let's solve this question. Okay, let's solve this question. So choose the eigenfunction of a stable LTI system. What is given? That your LTI system is stable. Nothing else is given. The only information is LTI system is stable. This is the only information. Right? If LTI system is stable, what does that mean? That ROC of H of S includes j omega axis. Includes j omega axis. Right? LTI system is stable, that means HT is absolutely integrable, that means ROC of H of S will include j omega axis. And if it is including the j omega axis, and if I say this is my H of S, this is my H of S, and my applied input is e to the power j omega naught, and ROC includes j omega axis, that means this j omega naught will be included. So what will be your YT? So you can put this S naught value in this one. So H of j omega naught e to the power j omega naught t. So that means e to the power j omega naught t is surely an eigenfunction, no doubt about it. There is absolutely no doubt about it. What about cos and sine? Surely they are not the eigenfunctions. Why is that so? Because for them the condition is H of omega naught should be equals to H of minus omega naught, which is nowhere mentioned. They did not say it is. They did not say that your LTI system is even, or they could have simply said that H of 2 pi by 3 is equals to H of minus 2 pi by 3. If this was given, then you could have said that yes, they would be your eigenfunction. But nothing has been mentioned about this particular thing. That means surely this is not the answer. Now the discussion will be around 2 to the power t. So let's take 2 to the power t. Xt equals to 2 to the power t, which I told you can be written as this thing, right? So here what is the S naught value? ln2. So if I apply 2 to the power t as my input, so what would be the output? Output will be, this is your H of S. So output will be H of ln2 2 to the power t. But H of S, what is the condition? H of S should converge at S equals to ln2. At S equals to ln2. This is the condition, right? This has to be true, then only you can say that this is the eigenfunction, then only you can say that this is the eigenfunction. When it will be the eigenfunction, then h of s should be converging at s equals to ln2. Now what is given? What is the information about ht is given? They are saying that ht is stable LTI, that's it. It is stable. Now if I say that my ROC of h of s is something like this, that it is having one pole and ROC is something like this. One pole at 0.5 it is having. One pole at 0.5 it is having, and this is the ROC. This is the ROC. If I am saying that this is my h of s, this is the, actually this is the s plane, sigma g omega. So this is the s plane for h of s. So ROC of h of s, I am saying that ROC of h of s, I am saying that it is real part of s less than 0.5. So is it stable? Yes. And surely it can be LTI. So it is a stable LTI system. I am satisfying the condition of the question. I am satisfying the condition of the question that it is a stable LTI system, and I can write down my HT as well. What will be your HT? E to the power 0.5t u of minus t, since the ROC is looking towards minus infinity, and then another negative sign. So this is a stable LTI system. I am satisfying the condition of the question. Now if this is your LTI system, if this is your LTI system, which is this one, okay, you are satisfying the condition of question and your applied input is 2 to the power t. Let me know what will be the output. Output will be tending to infinity. Why is that so? Because ln2 will be lying somewhere here. This will be the point of ln2. That means h of s does not converge at ln2. So output will be infinity, where output will be infinity. Yt will be tending to infinity. That means this is not an eigenfunction. So always it is not necessary, no? Always it is not necessary that for a stable LTI system, 2 to the power t will always be a eigenfunction. Always it is not necessary. But if they are saying that it has to be necessary, what they are saying, choose the eigenfunction of a stable LTI system, stable LTI continuous time system from the following option. That means always it should be satisfied, but always it is not necessary. But this is always necessary, because if ROC is including the j omega axis, then only it will be stable. So if they are saying it is stable, that means it will include the j omega axis. That means this j 2 pi by 3 will surely be there. This j 2 pi by 3 will surely be there. That means yes, this is the eigenfunction for sure. This j 2 pi by 3 will surely lie in the region of convergence. This will always surely lie in the region of convergence. Here will be your j 2 pi by 3. This will surely lie in the region of convergence. But it is not necessary that ln2 will lie in the region of convergence. It may lie, it may not lie. What if this was the ROC? Then it would be lying, right? But if this is the ROC, then ln2 is not lying in the region of convergence, then yt is coming out to be infinity. So how you can say that it is the eigenfunction? No, you cannot say. So only this should be the answer. But given answer was A and C. Given answer were A and C. And it should have been challenged. And we did not notice, I did not notice it, no one noticed it, and it was not challenged. And I don't think any student would have solved by this analysis, right? Because last year I did not take signal system course, because last year we promised only 7 subjects. So those 7 subjects we brought. This year I said that I will take the signal system course, and since no one studied from me, so I don't think they will be able to give the correct answer. So I don't think any student gave the correct answer in the examination hall. It might happen that someone would have clicked on only A, thinking that 2 to the power t is not even an eigenfunction, because in a lot of notes I have seen that they said that e to the power j omega naught t, this is only the eigenfunction. But actually the eigenfunction is e to the power s naught t and a to the power t. Considering that s naught is lying in the region of convergence and ln a is lying in the region of convergence, saying that a is greater than 0 and s naught is any real number or complex number or any imaginary number. So this is the concept of eigenfunction and eigenvalue, which we have already seen. Again repeating that e to the power s naught t and a to the power t will be the eigenfunction of an LTI system, considering that s naught and ln a lie in the region of convergence of h of s, with the condition that A is greater than 0 or and S0 could be real, imaginary or complex. So this conclusion we have already seen, but the important part, some student even miss this particular thing. So forget about those students, forget about those platforms, forget about those coaching institute. So but a to the power t, most of the students would know that a to the power t is also a LTI system. Sorry, a to the power t is also a eigen function. So they would have clicked on this. But rarely any student would know that ln a has to lie in the region of convergence. This topic is also missed in 90% of the textbook. Only in OpenM it is written that S0 should be lying in the region of convergence. In a lot of lecture you would see, everywhere you would see, they will not consider this point. So that's why they, even IITs also consider this is the answer. They forgot about this point, that ln a should be lying in the region of convergence. So they also consider this as answer. So this is where they went wrong. And this is where this was, C was given in the answer. Till this point it is given in the answer, but that is wrong. That answer is wrong, right? And why it is wrong, we have proved it. How we could have made this question correct? If I have said that stable linear LTI system and causal, if I have added another word causal here, then the answer this would have been also correct. Because if I had added a word causal, what does that mean? Causal means ROC will be looking towards plus infinity. That means ROC has to look here. If I say it is causal, then ROC has to look here, and I am saying that it is stable as well. That means it should include the j omega axis as well. So this kind of ROC you will get. That means somewhere pole will be here. More poles could also be there, but the right to the rightmost pole has to be in the left half of S plane. Are you able to understand this point? This point also we have seen that for a causal LTI system to be stable, all the poles should be lying in the left half of S plane. That means pole has to be here. It should include the j omega axis. Also, it should be looking towards plus infinity because it is causal. That means ln2 will surely lie in the region of convergence. And if ln2 is surely lying in the region of convergence, then answer C would be correct. So if causal was given, then the answer would have been A and C. But causal was not given here. So either they framed the question wrong or they did not think about a region of convergence at all. They should have thought of a region of convergence. Okay. Which was a big error, big blunder from everyone. I would say from everyone, from my side, from IIT's professor, from other coaching institute, from everyone, that was a big blunder. Okay. And should have been challenged. Now what we can do? We cannot do anything, right? So yeah, that's the conclusion. And that's it. This is the end of our eigenvalue and eigenfunction. I hope you enjoyed this lecture, and since this video will be posted on YouTube as well, so if you want to complete the signal system course in the best possible way, like actual understanding of the subject, if you want, like not only formula based but actual understanding of the subject you want, then you can purchase our course, which is available on our website. You can apply the code Fusion35, which will be applicable till 22nd, I guess. Okay, 22nd May. So you can apply this code, and you can get this course in 1,800 rupees. Okay. So actual understanding of the subject in a best possible way, remembering the minimum formula. This was just one of the video. You can watch other videos as well. What kind of depth has been covered in this particular subject? Okay, because this is the signal system is the most important subject of EC. I'm not saying just for the gate examination, but for everything, because every signal will have some frequency spectrum, right? It can have some frequency spectrum in S domain, omega domain, or it could be periodic. Then it could be written as complex exponential. So understanding every signal is very important. Everything around you is signal only. So signal system is the most important subject, and should be taught with the intuitions and with the proper understanding of the subject, not with the mathematics. So you will not find mathematics in signal system, but you will find the proper intuition of the subject. So if you want to study, then you can study. Okay then, yeah. Thank you very much. I hope you enjoyed this video.